Okay, guys, in this section, we're going to take a look at compounding interest, okay? And we're going to be using this general formula. A is equal to P times 1 plus R over N to the NT power. Now, you might have seen this in Algebra 2 or maybe even Algebra 1. It does show up on SAT, but on SAT and probably Algebra 1 and 2, you didn't have to solve for the exponent t. So that's adds a kink in the chain. But we know how to do that now because we just learned how to solve exponential equations. Okay. So A is called the annuity. So that's what something's going to be worth after a period of time. So if I put some money in a bank account that grows at some interest rate, that is what the annuity is. The P is called the principal or initial amount. Your R is your rate, your interest rate in a decimal. Okay, N is the number of terms or compounding period. So for annual interest, N is equal to 1, semi-annual is 2, quarterly is 4, monthly is 12, daily is 365. Now, if it says that it compounds continuously, which it does show up every now and then, you're going to take this term, and this whole term would be E, okay? So we're going to learn about POERT in the next lesson, but if you see continuous growth, that's going to be a little bit different formula, okay? And your T is time in years. Okay, so let's get going on this. If Courtney wants to have $5,000 in her account after 12 years that earns 7% interest compounded quarterly, how much will she have to invest initially? Okay, so this is going to be my A. This is my T. It's compounded quarterly. So my R is 7%. And I'm looking for the initial investment, my P. Okay, so A is equal to P times 1 plus R over N to the NT power. So 5,000 is what I'm looking. P, your R is 0.07. You got to convert it to a decimal. It's compounded quarterly, so your N is equal to 4. And we're going 12 years, so 4 times 12. Okay? So what I'm going to do is I'm going to put this in the calculator. I'm going to do 0.07 divided by 4 first. I'm going to add the 1, and then I'm going to raise it to the 48th power because 12 times 4 is 48. Okay, so I get 2.29, all that junk. Now, that's what this is right here. So I'm going to do 5,000 divided by that because it's being multiplied. So 5,000 divided by, I'm going to hit answer. Okay, and I get 2174.29. Okay, and money always goes 2 decimal places. Okay, suppose Heather has $2,000 to invest in an account that earns 10% interest compounded semi-annually. She wants to leave the money in the account until it has grown to an amount of $5,000. So this is your principal, that's your annuity, this is your rate. How long must she leave the money in the account? Okay, so we're going to be looking for time. So we say 5,000 is equal to 2,000. 1 plus your interest rate is 10%, so 0.10. It's compounded semi-annually. And I'm going to be looking for 2t. How long must she leave it in there? So your 2 is up there because it's compounded semi-annually. Okay, so the first step in this is I'm going to clean this up a little bit. 0.10 divided by 2 is 0.05. So 1 plus 0.05 is 1.05. So I have this equation that I can solve pretty easily now. Okay, so I'm going to do 5,000 divided by 2,000. Those zeros will end up canceling, so it's 5 halves. Okay, we're going to natural log both sides to solve for t. Okay, so we solve for t, and we get natural log of 5 halves divided by 2 natural log of 1.02. So when we put that in the calculator, we got to make sure we use parentheses correctly. So natural log of 5/2 divided by 2 divided by natural log of 1.02. If you decide to put it all in there at once, I'll show you how to do that. So it's 23.14 years. Let's actually go 3 decimal places. 136. Okay. So if I was going to put there all at once, natural log of 5/2 divided by parentheses 2 natural log of 1.02 in close parentheses like that, so we get the same answer. So you can do that either way. Sorry, my calculator habits from UIL take over sometimes whenever I'm showing you how to do stuff. So, okay, so if Scott invests $5,000 at 8% compounded quarterly, how long will it be before his investment has grown to $14,000? So this is my annuity, principal, my rate, and it's compounded quarterly, so N is equal to 4. So we take 14,000 is my A is equal to 5,000, and 1 plus compounded quarterly is 0.8 divided by 4, and we're going to go to the 4t power. So just like in the last problem, we're going to clean this up a little bit. So 0.08 divided by 4 is 0.02 plus 1, so 1.02. We're going to cancel those zeros. Okay, so it's a simple exponential equation we can solve. So 14 divided by 5 is equal to 1.02 to the 4t. We're going to natural log both sides. Okay, and then we're going to divide the 4 natural log of 1.02 to the other side. So we get natural log of 14 over 5 over 4 natural log of 1.02. Okay, so we do natural log of 14 over 5 divided by 4 natural log of 1.02 parentheses parentheses, and you get 12.999 years. So almost 13 years. Yep. On to the next page. Okay. It says, if I choose to invest $9,000 compounded at 7% over 10 years, how much money will be in the account if it's compounded annually, quarterly, and daily? So what we're doing is we're looking at changing the compounding, okay? So nothing really changes except for your N in this problem. So A is equal to, your investment is $9,000, 1 plus, your R is 0.07, it's compounded annually, so it looks like that. So we get 1.07 to the 10th power times 9,000, and we get $17,704.36. Okay, now if it's compounded quarterly, we're going to change our N to 4. Okay, so we'll do 1.07, 0.07 divided by 4 plus 1, raise it to the 40th power, and we're going to times 9,000. So we get 18,014.38. Okay, so just going from an annual interest rate to, or compounded annually to quarterly, you can see that you're making about $300 more, okay? Now, if it's compounded daily, so we're gonna assume that there's 365 days in a year. Sorry. So we did 365 times 10. See if I can get this to stop shaking. Okay, so we're going to do 0.07 divided by 365 plus 1 to the 365 times 10 power. Okay, and then times 9,000. So you get 18,122.56. Okay. So, last example. It says, for my retirement, I take $25,000 invested into an account that earns 4% interest compounded quarterly. How long will it take to retire with an amount of $1 million in an account? So your final amount is $1 million. I have $25,000 to invest initially. My interest rate is 4% and it's compounded quarterly. And I'm looking for how long it takes for me to retire. Okay, so I'm going to cancel 3 zeros. Cancel 3 zeros. And let's go ahead and 0.04 divided by 4 is 0.01. So we get 1,000 is equal to 25 times 1.01 to the 14. Okay, so when we go to solve this, do 1,000 divided by 25, and we get 40. Okay, so to solve this, we're going to natural log both sides. Okay, so we get t is equal to natural log of 40 over 4 natural log of 1.01. Okay, so natural log of 40 divided by 4 natural log of 1.01, close parentheses like that, and you get 92.682 years. Okay, so here's why compounded interest questions are important. So say I'm fresh out of college, I'm working my first year job. Right now, they're saying that you realistically need $2 million in your 401k to retire comfortably. Okay, so say I start my job, I'm working, like I'm a teacher, I started at 23. Okay, so if I initially had $25,000 and I invested in an account that earns 4% interest, it would take me 92 years to retire, which is very, very depressing, okay? So that's why this stuff is important. You have to know where to invest your money, what the risk is, what the yields are, what your interest rates are, and you know, that all is determined by what the economy is doing. You know, say you invest in the stock market and the stock market crashes. Recently, when the stock market crashed, I know some people who were getting ready to retire had over $1 million in their 401k and lost $350,000 in one day. Because their retirement was invested in a company. So they can't retire now because they don't have enough money to live comfortably off of. So that's why you have to diversify your portfolio. You have to and be smart about interest rates. Same thing when it goes, we're going to buy a house or you're going to buy a car. The more the interest rate is, the more you're going to pay on the loan. And who wants to pay more money? So that's why credit is important. That's why it's important to know how, if someone's messing with you in your calculations, like they might be trying to make some money on the back end, but you have enough knowledge of how interest works and you've done enough research to where you know if you're getting screwed around or not. So it's super important that, especially with, you know, these problems and stuff like that, that you know what it's going to take to retire and how to save your money and how to invest your money wisely. So, I mean, I'm honest. I've done it before. You know, I look at these numbers all the time. So it's important. It's an important part of life. So if you ever ask yourself, oh, hey, how am I going to ever use this in life? Well, everyone uses money. Everyone needs money. And this is a very good lesson on how to apply that. So thanks and have a good day.